So hello everyone. Today we are going to start with this particular problem, that is top k frequent elements. And in this particular problem, the problem states that we have an input and let the input be 1, comma 1 and 2, comma 2, comma 2 and 3. So and let k be equal to 2. These particular variables are provided as an input, right? So we have this input list and we have this k, and we have to find top k frequent elements. So what do I mean by this is, let's say in this particular list we have 1 comma 1 2 comma 2 3 times, and this we have 3. So the most occurring element is 2 in this particular list. So we got 2. And the second most occurring element is 1. So we got 1. As the value of k is 2, that means we are done with our final result. If it was, let's say, 3, then we also have to include the third most occurring element. That would be 3 in this particular case. So how can we approach that? So there are multiple solutions to deal with this particular question, but today we are going to solve this particular question with the help of counting sort. So in this particular type of sort, there will be a bin kind of system. So these particular bins will represent a count. So let's say this count is 1, this count is 2, and this count is 3, and so on till n. So n will be the size of the input array. And why it should be n? Because these all numbers represent a count. And let's think about the worst case complexity of this particular input. Let's say what can be the worst case? That will be all numbers are distinct. And let's say if the list is 1, 2, 3, all numbers are distinct, the size of this particular list is 3, and that will be the total possibilities of our bins. And in these bins, what we will do is we will aggregate all these numbers that are in the list. Let's say we got 1, and it will go here because it occurred only once till now, and so as 2, it also occurred once, so it will also go with 1, and 3 also occurred here. So we got an array 1, 2, 3 in this particular bin, that is 1. And similarly, it goes on. So we can use this bin type of approach to solve this problem. So let's get started with the code. So let's get started with our solution, right? So, yeah, let's start. So we will do the bin approach. To start the solution, what we're going to do is we're going to start with our variables, and what we're going to use is a count. So a count will be a dictionary, and it will store all the numbers in the form of count. So we will take the count of these numbers that we encounter on the way. So that can be, for example, if our list is 1, comma 1, comma 2. And what we need to do is we have to create a dictionary, and that will start with the element, and it knows the count it have. Let's say the 1 occurred 2 times and 2 occur 1 time. So that will be the thing we will do with dictionary. And then we will do another thing, that is frequency. So I told you about the bin approach that I'm talking about. So to do that, we need to make that count as our index. So to make the count as our index, we need to change the structure of it. So what we can do is we're going to use this frequency array or list to store the elements in the form of in the index, and each index represent the count. So let's say the count. Let's say the count can be. Let's say the count can be 1 comma 2, 1 comma 1 comma 2, and this can be our input. And what we're gonna do is, because of the bin approach, in the bin approach we need these bins, and each bin represents the count. So if the first index, if the first index has 2, that means it occur once. And okay, so there will be an outer list here and comma. So the second index is represent the second bin that I was talking about. And if the 2 is inside it, that means this particular element occurred twice in the input array that we got. So that is what we're going to do in the frequency. So to do that, I'm going to do is I'm going to initialize it first. So I'll do a for I in range, and the max it can reach is the worst case, that will be all elements are distinct, and that will be len and +1, right? So that's how we're going to initialize. So this is the initialization part of our problem. Now we're going to start with our part 1. So the part 1 will be how we are going to append all of that in our dictionary. So to do that, what we're going to do is we're going to do a for loop here. The for, let's say n in nums. For n in nums, we have to include that whatever we find. Let's say we found 1, and we will first check in our dictionary that is that particular element is already in the dictionary. So we will do, what we're going to do is if n is in count. If it's in count, let's say if it was 1, let's say it was initially 1, and we found it one more time. So what we're going to do is we're going to just append once, and we're going to just add on it, and we're going to just make it 2. So that will be count n equal to 1, and that you're going to do the same thing that I talked about right now. And if it doesn't exist, if it's not in the dictionary, so we will have to initialize it with count 1, because we found the first occurrence of that particular element. And so we are done with the part 1, and we're going to do the part 2. So in the part 2, we're going to deal with the frequency variable that we have created. And to put all these data that we have in the count, what we're going to do is we're going to do a for loop, and a for loop will be n comma c, that will represent the key and the value pair in our count dictionary. And it's gonna, because of this particular items function, we will get a key and a value, and it's gonna store in n and c accordingly. So now we have the key and a value, and what we're gonna do is for the bin approach, we have to make our count the index, which we already have initialized, and we just have to put accordingly. So to do that, what we need to do is we need to go to the frequency, and that will be the frequency. And in this particular frequency, let's say the index is what? It's the bin, and bin represent the not count. And if the count is 1, let's say the C is 1, what we're going to do is we're going to append the particular number in it. So if the frequency is C, so C is, let's say C is 1, for example, it will, so C is 1, that is the C is 1, so that means the index is 1 and the count is 1. So the number of elements with count 1 will be appended in this particular index, and that's what this part is doing. So okay, so let me just give you a quick example of that. So let's say our initial array is 1 comma 1 comma 2, like we have discussed so far. So what it's gonna do is the bin that we have created. So these are the bins 1, the bin will be only created like this. There will be 4 bins created, but ignore this one because this is the 0th index. We have to ignore this bin because we can't have an element with count 0, right? So, so we have to focus on these 3 bits. And now, so as we do this, it will go to C, and the C is the count, and then the count is 1, and it will check the element in this one. So it will be 2 right here. And if it's 2, so if this particular index represents the count and it 2 will only occur once, so that's why it belongs there. And similarly, it will check the key and the value, and its C is that 1 occur 2 times as from this particular dictionary, and hence it will put 1 here. And so this will be looking like this, the whole frequency variable. So we are done with the second part. Now what we have to do is we have to go to the third part. So for the third part is the result. We are finally reaching the result, and we will just initialize the result with res equal to empty list. And to do that, so we got this particular frequency, and now we just want to extract the information from this particular frequency. So what we want is top k frequent elements, right? So for top k frequent elements, what we have to do is we have to move right to left. And why do you have to move right to left is because these elements that are inside the list, that is the frequency list, is starting from 1 count, 2, 3, 4, and in the increasing order of counts. And we want the most occurring elements from the top k, right? So the most occurring elements, and the second most, and the third most, and so on and so forth. So what we're going to do is we're going to start from the left side, from the right side to left. So for that, we will do is we will run a for loop that will be in reverse order, and that will be in length of the particular frequency. And to do that, we will use a step function that will be -1. So it's starting from the last index, and the stopping point will be 0, so that it will only run till index 1. So it will execute 1, and this is excluded. So 0 index is not included in this one. That's what we want because it doesn't serve a purpose. And again, -1, that will be in a decreasing order. So now we are inside the loop. So what if we have 5 here? So let me just rearrange that 5. So if it has this particular index, that is the second and the second bin, so it have 1,5. So now what we have to do is, in this case, we have to also run another for loop. Let's say let's say j in range, not in range. Let's do it without a range. We can just do frequency, and we can do frequency, and if it's in like seconds, so we can just do I, and we will iterate through all of that. And when we are iterating, what we have to do is we have to append it in our list, result list, basically. And yes, we have appended the particular element. Let's say we have appended 1 and 5. And if the k is equal to 2, that means we have to exit the loop. So to check that, what we will do is we can just check the result. So we want let's say we want k is equal to 2, and we want top 2 elements. Obviously, the result can't be more than 2 elements because that's all we want, right? So what we can do is then we can just do an if statement, if len of result equal to k, and yeah, that's it. We just have to exit it, and this we can just do return result, and that's it. And we don't have to check again for anything because this particular line will obviously execute at some point of time, because the result will obviously going to be equal to the top k elements that from the input that we get, and obviously we will at some point reach this written statement and it will written. So let me just start and let's submit it and check if it's running accordingly. And it says it's accepted. Let me just make it a bit down. Right. And yeah. And let me just see the performance of our particular solution. So the runtime, it only took 87 ms, and I think because the input was not that big, and we have beat like 76% of the users in Python. And how we beat all of those, because we used this particular bin approach to it. And this bin approach is really good in dealing this type of solution in this type of questions, is because it's linear time. We are just doing a big O of n. Let's say we are doing a big O of n here in this line, and we are just doing a big O of n here. And when we just do a big O of n plus big O of n, so it's basically linear time, and that's why our solution is like really fast at this point. And even though we are doing a for loop, like a nested for loop here, but we will, as we are doing it, let's say in the worst case scenario, we will just go through the list only 1 and 2, and let's say we are just doing it 1 comma, let's say we are having these elements, all of these elements here, and we are doing a loop here. Even though the loop is, we are doing a nested loop, it doesn't mean that it's n square. It will be n big O of n, because it's linear. It's linear because as we do all of that, we don't have to don't have to do it again and again. We will just stop it right here after iterating through this particular list, and that's it. Right. So that's it for our session, and watch.